The weird thing about a home is you buy a $500,000 home and you get a 1-year warranty. What's supposed to break in our home in 1 year?
So what is geothermal? It is the gold standard in home heating and cooling. This is a proven technology. It's been around for many decades.
Cleaner energy options, just more energy efficiency, less carbon emissions. Pick the driver it is, and when it comes to heating and cooling, and water heating for that matter, it's a significant portion of the home's energy consumption.
I think it's up to the builder to educate and explain to their buyers what that really means, and to use language that makes it sound like we built you an amazing home.
Talking about energy now, we got 3 great speakers. We got Bryan from Dandelion. You're gonna learn a lot about geothermal. I've had some really interesting experiences with community level geothermal in Austin, Texas. There's a kind of a premier community down there. 3,000 homes will be built eventually, all geothermal, heating and cooling. I've interviewed dozens and dozens of homeowners down there. They absolutely love geothermal. Their utility rates are ridiculously low.
All right, geothermal heating and cooling. I'm sure most, if not all of you, have heard of geothermal heating and cooling. Maybe some of you have been involved in projects where it's been installed. Today, I'll give you a little bit of insight into who Dandelion Energy is, our role in the geothermal space, a high-level overview of how geothermal works for any of you who might not be familiar, and then some of the ways that we're innovating with a special focus on policy innovations today. I know, very exciting, but it is meaningful in making geothermal more accessible to folks. Dandelion was launched and founded out of X, which is the research and innovation lab for Google's parent company, Alphabet. We came to market with the mission of making geothermal more affordable, more accessible to folks. This is a proven technology. It's been around for many decades. We know when it's designed and installed properly that it works really well and that it's the most efficient heating and cooling system available. How do we make it more affordable and more accessible? In large part through scale, economies of scale. Scaling in a way that really has never been done with geothermal before in this country. In part through innovation, innovative products, innovative installation techniques, including lowering the impact and quickening the speed of drilling what's called the ground loop. We're also very proactive on the policy front. We have full-time regulatory affairs folks who are working with regulators, policymakers on a federal, state, and local level to unlock incentives for homeowners and businesses and create a more favorable environment. So what is geothermal? It is the gold standard in home heating and cooling. It uses the Earth's constant temperature. Depending on where you are geographically, that constant temperature underground varies, typically somewhere between 55 and 70 degrees. And we use that temperature to deliver hyper-efficient, reliable, comfortable, year-round space conditioning. How does it work in more detail? There are 3 primary components of a geothermal system. You have 1, the exterior component, that's called the ground loop. The second component inside replaces all the other mechanicals. This is the ground source heat pump. And then we have the third component, which is just the distribution system. Typically that's ductwork for forced air. So you can get both heating and cooling through one distribution system. But you can also do water-to-water systems, in-floor radiant and the like. With the ground loop, typically we're drilling boreholes that are only about 5 inches in diameter and usually somewhere between 200 and 500 feet deep. You can go deeper, but most applications are 200 to 500 feet deep. We put a U-bend pipe into the borehole. That U-bend pipe is filled with water, and the water circulates down one end and back up the other, and it's just engaging in thermal exchange with the Earth. So we're capturing the Earth's temperature and using that as a baseline for hyper-efficient heating and cooling. In this case, you see one borehole. This is imagined for a small single-family home that might only need 1 bore, but if this were a multi-family apartment building with hundreds of apartments, we might drill 100 or more bores. So the number of bores and the depth of the bores is typically in correlation to the total heating and cooling load for the building. Once the water captures the Earth's temperature, it goes into the heat pump and again engages in thermal exchange with the refrigerant in the heat pump. And then depending on the season, the refrigerant either goes through a compression or a condensing cycle to heat or cool the refrigerant, then up to the air handler, goes through a coil, and the air is pulled over that heated or cooled coil, conditioning the air, and then we blow that conditioned air through the ductwork throughout the building to satisfy whatever the thermostat is calling for.
The advantage there is that in the summertime it's 102 degrees outside and you're trying to cool, so the air that you have outside is 102. In the wintertime it's 20 and you're trying to heat it, whereas you've got this kind of constant source of temperature of 65 or 68 degrees or whatever, summer, winter, etc. Just makes the whole process more efficient.
That's exactly right. We're going to maintain constant efficiency throughout the year because we're using a constant ground temperature, whereas air source heat pumps are using the variable outdoor air temperature, and therefore their efficiency is variable throughout the year. This is just a graphic to show you that in the winter, we're essentially extracting heat from the earth and using that to heat the home. And in the summer, we're essentially pushing heat from the building into the ground to exchange that for cooler. So industry challenges, what builders are facing out there with a special focus on HVAC systems. We know there is increasingly a push for all electric high performance buildings. Codes are tightening, the need to comply is strong, and everything is being enforced pretty stringently at this point. We need equipment that is durable in various climates and environments. Where I live in New York State, it gets quite cold in the wintertime. Air source heat pumps have their place, but they also have outdoor condensers that are exposed to the elements, and that makes for higher maintenance and shorter lifespans on the equipment. Cost stability. People want stable costs throughout the year to condition their buildings. And then of course, we're dealing with noise and space issues. Outdoor condensers are loud, they're not especially attractive to look at, and they take up space. We have regulatory pressures towards electrification, stretch code requirements that are accelerating across jurisdictions. We also have, in many places still, Energy Star or HERS scores-based compliance measures that are tied to codes and incentives. So if you're gonna satisfy code, if you're gonna get the incentives, you have to reach certain Energy Star or HERS standards. Utility constraints are very real. We're seeing bans on natural gas main extensions. We're also seeing exorbitant fees imposed, increasingly so, on gas line extensions. And then you're also dealing with potentially delays waiting for utilities to run required infrastructure, whether that's electric lines, transformers, or gas mains. And these systems are all increasingly under strain, right? This is why utilities are looking for alternatives, hyper-efficient, electrified alternatives that remove some of the burden on their existing infrastructure.
So there's a lot of talk these days about electrical grid capacity because the data centers starting to suck up more and more of that. Has started to become a permitting problem for large master plans. You create a 200, let's say unit housing project. You got to look at, well, what's the electrical demand going to be on the grid? It seems like with geothermal, you could lower the electrical demand dramatically of a small community or a large community.
Part of the reason that utilities like this technology, air source heat pumps, again, they're less efficient, they require more electricity. When it gets extreme cold outside, it relies more on auxiliary heaters and it engages in defrost cycles. This results in higher peak load demand on the electric grid, which then means the utility needs to do something to meet that peak load demand. And in some instances, that means building backup utility plants that are only fired up for certain times of the year and otherwise are just sitting unused. That's very expensive and complicated logistically and from a regulatory perspective. You also have the community and the political dynamics, right? We know there's NIMBYism. We all know that there's a housing shortage, yet we are seeing faster approvals for projects that are all electric, quiet, and visually unobtrusive. Boards, whether it's planning boards and neighbors alike, they respond favorably to these low noise, condenser-free mechanical systems. We're finishing up a project with Toll Brothers in New Jersey right now, where exactly that played out. They're dealing with some more urban infill type developments, stacked townhomes. And, Toll's, they build themselves as a luxury brand. They don't especially want to litter the outside of their buildings with condensers on every patio outside the kitchen building. And communities don't want to see that either. And they're seeing approval accelerated because they're going with geothermal overall. So what are your options, right? When you're looking at HVAC systems today, it's primarily status quo, natural gas from air and plus air conditioning, where they still allow that. In New York State, where I live, new construction is now required to be all electric. You have air source systems, right, which rely on outdoor air, which means variable efficiency and condensers exposed to the elements. And you have ground source heat pumps, which relies on a constant ground temperature and is the most efficient option now. So from regulation to buyer demand, geothermal does turn compliance into a competitive advantage. In the housing market as it stands today, it's good to have this differentiation, especially if you can do it with a system that's exceptionally reliable. Again, ground source heat pumps all inside the building in the mechanical room. They're very reliable. You expect these heat pumps to last 20 to 30 years. That's 2 to 3x the life of most conventional equipment. We expect the ground loop to last the life of the building. Hyper efficient, I've touched on that, but that also means in most climates, 30 to 50% lower energy bills for the tenant or the homeowner. These systems are healthy. There's no emissions associated, no point source emissions, so we don't have combustion or risk of carbon monoxide poisoning. It delivers clean, healthy air. There's a lot of air circulation in a geothermal system, so you get really good air quality. You also get even distribution of the conditioned air throughout the building.
I saw at Whisper Valley as they, the geothermal community in Austin, as they were designing the homes. Originally, they just took plans from other communities and started building those plans. But eventually what they figured out is because they didn't have combustibles, that utility closet didn't have to be on the exterior wall. Right? I mean, so they could start to move it around, and it started to change their whole design. They started to use, kind of unused spaces under stairwells and different things like that, right? That were underutilized spaces that normally you would never use a utility closet, but it became a more efficient envelope then for usage of the home because they didn't have to deal with all the penetrations and the combustibles.
Might say, well, what about the ground loop though, right? We need to run the ground loop to the heat pump, but in many applications, we're actually drilling the ground loop in the footprint of the home before the foundation is laid and just bringing pipe stubs right up into the mechanical closet when the foundation is laid around it. Minimizes the penetration into the building wall, also eliminates the need to trench the lines into the house from the borehole location. That said, if inside the footprint is not an option, we can drill outside in future green space, in future parking area, and then tie the line in horizontally in a trench into the building. What can make these installations more viable? Again, I mentioned I have a bit of a policy focus today, and there are policy levers that you can use to make these systems more accessible. Many states see utility companies offering rebates for these installations. I already touched a little bit on why utilities are interested in seeing these hyper-efficient electrified systems installed. So many of them are incentivizing them with either per ton or per system rebates. Many states are also offering tax credits to either reduce the upfront cost burden on the builder or to offer bonuses to the future home buyer. Same thing with sales tax exemptions in many states on this hyper-efficient electrified equipment. And then furthermore, there is a growing renewable energy credit offering GRECs, geothermal renewable energy credits. These are levers that are available on state and local levels. And then we have federal level levers as well. I'm sure you all have heard of something called the Big Beautiful Bill. Some tax credits that have historically been available go away. That includes 25D. That's the consumer credit that was kind of generally called the solar tax credit for individual family or individual single homeowners. That credit is going away as of the end of this year. So is 45L. That was the Energy Star and Zero Energy Ready Home tax credit. Still good till the end of 25, going away in 2026. However, Section 48, the geothermal commercial tax credit, remains intact. That's great for multifamily commercial buildings, right? If you're building a multifamily apartments for rent, that satisfies the commercial criteria. You can get up to a 50% tax credit. That's 50% of the entire system cost. Drilling, heat pumps, the infrastructure inside the building. If we're talking institutional applications, whether it's airports or universities, those also qualify for the geothermal commercial credit. And furthermore, the bill opened up options for geothermal leasing. This was not viable from a regulatory perspective until HR 1 was passed. That's a pretty exciting development and gives us an alternative to offer single family homeowners who are no longer going to be eligible for 25D.
I've seen residential single family home geothermal deployed in two ways. One is You put it on an individual lot. It's an individual homeowner. The homeowner bears the expense of the drilling, the well, the groundworks, all the equipment, etc. But I've also seen it done the other way, where the developer, whether it's a 200 homes or a 3,000 home development, says, I'm putting in all of the groundworks. And it's not even underneath your home. And I'm actually creating a utility loop in the neighborhood. So just as there's electricity going by every home, and there's water going by every home, and there's gas going by every home, there's a constant ground source liquid going by every home as well. And you tap into it just like utility. And the developer then owns utility. In that case, that would all apply to this commercial tax credit, wouldn't it? Because it's not an individual resident. I'm becoming a geothermal utility provider to a community. Is that something Dandelion's working with, or have you seen that? But it seems like the new tax code works really well for that kind of deployment, and then that takes all of the cost away from the homeowner.
You're talking about district thermal loops
Mm-hmm.
that houses can tap into. There is a catch.
Uh-oh.
There is a catch, which is that you can't separate the heat pumps from the loop if you're claiming tax credit. So the entity that owns the loop
You'd need to
must
own
also own the heat pump itself.
and then they'd have to lease the heat pump or something like that, right?
Correct.
But then you said it allows leasing, so
Yeah, right. And actually, my next slide, I'll get into a little bit of detail on the leasing option that we're offering. But what I will say, district loops versus an individual loop per building.
Yep.
There's pros and cons to both.
Yep.
Where we've seen district loops, like in Texas with Whisper Valley, they used an improvement district platform that effectively had the loop funded by municipal bonds, and then the homeowners or the future homeowners are paying that money back through their tax assessment over time. That's how they funded the upfront costs for the loop. The pro of that is what I just said. You can take advantage of platforms like that to fund the loop. The con is that the district loops are significantly more complicated to operate and install. You need specialized controls. They're less efficient because you need massive pumping power in order to circulate the liquid through the loops. So I think there are good applications for district loops, especially where you have a mix of building types. In other words, some buildings that are cooling dominant and some buildings that are heating dominant, because then they begin to balance the impact on the loop and make the loop very durable over time. Dandelion's general platform is built on individual loops per building. And the reason we go that way is because it is simpler and it is cheaper to install compared to the district loop. Dandelion just 1 week ago launched the first leasing program in the nation for geothermal systems. So we've started in just 16 states with an eye towards expanding nationally over time, but for now it's 16 states to start. Builders can now integrate geothermal on cost parity with traditional HVAC under these leasing programs. New homeowners will then have to pay a lease fee for the geothermal equipment, which includes the heat pump and the ground loop, but we're talking a modest fee between $15 and $40. So like as low as $150 a year to lease your geothermal. The lease is envisioned as a 20-year term, but the homeowner will have option to buy it out at year 6 or year 12 if they don't want to maintain a full term of the lease. And the buyout is also like shockingly affordable. This allows homeowners to enjoy all the benefits of geothermal, longer lasting equipment, more efficient, lower operating costs. We all get to enjoy the benefits of the cleaner and more affordable energy that the geothermal system. So in closing, my last slide, how does Dandelion partner with builders to do this? Well, we offer end-to-end expertise on ground loop design, engineering, and turnkey installation of that ground. So we design the loop, we install it, we do all the drilling, we'll do the horizontal tie-ins to the building, and terminate the ground loop at a manifold and the mechanical work. We offer best-in-class equipment. So we have proven, reliable heat pump distribution and flexible cabinet options, so we can accommodate different form factors inside the building. Seamless integration, meaning we partner with your existing HVAC contractors. We want you to maintain your relationships with your existing mechanical installers, and we will provide technical support and training to them as needed so that they're all confident and comfortable installing ground source heat. And we'll stick around through QA/QC of the system to make sure it's operating properly. And then of course we offer policy and incentive support so that you can maximize your capture of state, local, and federal dollars to support the project.
Okay, so my name is Jason Thorson, Director, National Accounts Group for Daikin Comfort Technologies North America. Before I get going, I used to say show of hands who has heard of Daikin. Raise your hand, please, if you have not heard of Daikin.
Oh, look at that. You got
even
some,
still,
some work to do.
Yeah, so I've been with Daikin 9.5 years. There used to be quite a few more hands in the air. And then relative to this discussion, energy codes, tax incentives, before that, 4.5 years with a company called Clear Result. If you're familiar, was the largest, not sure anymore, energy efficiency consulting firm. And then 7 years in residential new construction before that. So bringing it all together for this subject matter, let's talk about how we fit into this landscape. See the upper left, founded in 1924. Daikin turned 100 last year, 2024. Global headquarters out of Osaka, Japan, North American HQ out of Waller, Texas. I just like to show that. So some of the family of companies since 2008 in North America, over $9 billion invested, some of that acquisitions, just showing some of the logos that may be familiar to you all. Goodman and Manna, Modally was brought up earlier, which has shocked me. Venstar, Quiet Flex, all things HVAC. Daikin does not make cars. We do not make televisions. We do make refrigerants, oils, everything associated with HVAC. But Daikin truly is trying to be the best at being the value-added heating and cooling manufacturer partner to builders. Globally speaking, market share position #1 in HVAC. Specific for today, I just show a snapshot here, market drivers for energy efficiency. You know, we talk energy codes, obviously you have to adhere to that. I'm down here visiting Dallas from just outside Portland, Oregon, where we're a little bit more of an incentive state. We're our neighbor to the north, Washington State. They like aggressive energy code. So the carrots and sticks, and I'll touch on a few of these and where our products really fit in. But what you see here with this map, if you're familiar, these are some of the energy efficiency organizations across the country, Northwest Energy Efficiency Alliance in the upper left, Southeast, et cetera, et cetera. The point being that consumers are becoming more and more aware of these incentives, of these initiatives to have, whether, like Bryan said, cleaner energy options, just more energy efficiency, less carbon emissions. Pick the driver it is, and when it comes to heating and cooling, and water heating for that matter, it's a significant portion of the home's energy consumption. So you see there, California is amongst an all-electric standard. As Bryan said, New York, they're taking away gas stubs. City of Seattle doing the same thing. So you are going to see that happening more and more across the country as some of these municipalities, states, or we'll get to the federal government side of things here in just a minute, as these initiatives try to get us to a more energy efficient and renewable energy future. So there's a lot going on there. So I'm actually going to cruise through. I mean, it would be comic.
Read this?
Yeah. No.
Just all take a minute and read this.
Bryan did, I mean, we're going to really focus on the 45L, right? Because that's what I put together for this. But it's comical to think about if we were doing this exactly 1 year ago today, and then now where we are with. I'm glad somebody had to, pop the big beautiful bill, for all of us, and I believe June 30th, July 1st, 2026 is the cutoff point. Just wanted to show, yes, single family homes, multifamily dwellings. I assume most of you are familiar to the Inflation Reduction Act, and for this subject matter, did just want to put that up there, and I'll show technologies that fit into that here in just a minute, but it is the tax credit for the builder, or as Bryan showed with his, the 25C for the actual consumer. Being in Texas, I mean, there's utility programs across the country, right? What's going on in my neck of the woods outside Portland, Oregon is different than we're about to see here in Dallas, Texas. So coming into this subject matter and how HVAC fits into it, I did just do a snapshot of where we are. Then it should be noted, I've had a lot of conversations where you have an energy code and a utility program and they say, well, that doesn't make sense. Why doesn't the utilities give incentive into the code? Well, if you look at it, right, a state building code or an international building code relative to a utility program, the utility program often will say the structure needs to be 1 year or older, which is silly, right? You build a new home, put in electric resistant zonal heaters. Oh, it hits a year. Now here's an incentive to go with a mini splitter VRF. There are, however, some new home programs out there. You look at the numbers, it's really, maybe not going to move the needle dollars and cents wise to truly change behavior. Right? The definition of an incentive is to change the builder or consumer's behavior. They're out there, they're growing. We'd like to see them grow more because for Daikin, we have every HVAC product you can imagine. We have the lowest SEER single speed AC unit, code minimum, just to be legal, all the way up to leading edge technologies, highly efficient. So we're obviously trying to innovate and differentiate toward the more advanced stuff, but we also have to take care of the today's needs of consumers and builders in markets. So some existing incentives, CenterPoint Energy Houston, so Dallas Fort Worth, you see, you know, how some of these dollars and cents come together. And one part of it is the dollars and cents, and the other part we would like to see is more not just transparency, but the consumer to be aware of it, right? Because as a consumer, you know, sometimes you'll have a utility program like a product list, whether it's thermostats or otherwise, and it's not about the $100 or $150. The consumer wants to know that what the contractor or builder is presenting and selling to them, it's validated, right? It's credible. It's on the list, if you will. So some core technologies, how to tie this together. So for Daikin, and we call these, you know, our core competencies, core technologies. We're really focused on the inverter and heat pump side. Refrigerant control, that's a lengthy discussion if you want to talk about how we change the temperature of refrigerant for added efficiency. But also too, with regulation, for those not aware, January 1st of this year, the refrigerant protocol changed at the manufacturing level, right? So with Daikin, and it would have been too long, we went with R32. Daikin invented it. They removed all the patents on it, so it's wide open to the market. Globally speaking, it's been in existence and being widely used, say Japan, parts of Asia, pushing 15, 16 years. So it's not like they just dreamt it up. Tens of millions of units in the global market functioning today. Other brands chose other paths. There's another A2L called 454B. There's even some others out there that are just kind of a one-off, but also part of the codes and standards change. It's been a big deal, right? Telling manufacturers that there was a cutoff of making that product from 410A to R32. But for what we're looking at today, I'm talking about heat pump and inverter. So geothermal, obviously very advanced, a ton of benefits there. Well, the path to, let's say, strategic electrification, getting us to goal, to Tim's point about easing strain on the grid for Daikin and many HVAC manufacturers, it really is going to come down to heat pump, going to come down to high efficiency, all electric. But for us, we really are focused on the inverter side of things. But really, inverter technology being true variable speed and what that offers, lowering monthly energy bills, right? Because its ability to ramp up and down and really save money. We've experienced it. Portland General Electric this year, we had a significant rate increase. They credited it to forest fires. So I do like to tell decision makers, I don't anticipate any utilities rolling back their price per kWh anytime soon.
And I keep telling builders, I think we're going to be in a rate increase crisis with respect to it. If you look at the maps of where the amount of energy being demanded by data centers is starting to outstrip. There was a data center negotiation in Virginia where they wanted 100% of the output of the utility.
Yeah. Tim, you could give me, so in my,
it's like, well, what does that do to rates when one customer says, I want all the energy that you can generate and forget about houses, forget about industry, forget about buildings. We want it all.
You could get me riled. So in my neck of the woods with our hydro, like place like Wenatchee, it's about one cent for a kWh. And you have some of these smaller depressed.
Can I get some of that?
Yeah, no kidding. You should see how many Bitcoin and all these mining operations are right there, because there was all this vacant space because the city itself is a bit depressed, right?
Yep.
And then so you had, I'm not going to name the names of the big tech companies you could imagine, but these data centers, right? They made a deal with the devil. They said, hey, we're going to bring jobs, this and that. Well, this data center that consumes the energy of a city, it's ran by like 3 people, right? And everybody's rates are, so anyways, there's that whole side is a different political, but you're exactly right.
But rates are going to go up.
Absolutely.
Energy is going to get expensive. And as builders, we've got to figure out how we're going to navigate that whole thing.
Absolutely. And even the all electric path, Bryan touched on it a little bit, but like say in California, I mean, it's smoothing out now, but coming out of the supply chain crisis of the pandemic, I mean, you had houses sitting because they couldn't get the proper electrical vaults for the foreseeable future. And then you introduce renewable energy and storage and all these other amazing technologies. And that's where we really lean into heat pump with inverter, because the other side of that coin is extremely inefficient cooling or heating solutions that really just flips the whole value prop on its head. So comfort without compromise, I'm going to show that here in a minute. Feel the difference, hear the difference. I'm glad Bryan pointed out the noise ordinances in more and more cities, Seattle, Irvine. I wish more and more communities would adopt noise ordinance, because I mean, now that you see the alternative to be quite quiet, it's so noticeable to me to walk down the street and hear single speed AC bangers just slamming on and off, you know, just it's obnoxious, right? Like why, in the house myself and my family live in, I listen to George's AC unit next door go on and off all summer long. Anyways, here's the difference. And then invest in tomorrow today. That's just all about being efficient, sustainable. Obviously, if we're using cleaner energy, less carbon emissions. The graph on the left, so when we talk variable speed, so inverter-driven technology, the analogy for a car is kind of the easy one, right? Where a single speed AC unit, it'd be like a car that has 2 speeds, 0 and 55. It would be insane. It would be crazy, very inefficient, take down a ton of energy, gasoline. Where variable speed, its ability to gently ramp up, and let's just say your set point is 72 degrees, it really dials in that tight delta to the set point because it has 600 odd positions of variable speed. So it can just very gently heat a little bit or cool a little bit as needed, where we have like certain mini split products, when it ramps down and gets to the set point, it consumes the equivalent of like an 8-watt light bulb, right? Where a single speed AC is just that. It does 2 things, 100%, 0. So if your number is 72 degrees, it's going to overcool you to 68, and then it's going to let the temperature creep back up to 75, 76. So now you're sweating again.
There's another really interesting play on this because some of this smart inverter technology allows you to operate AC systems off of home battery backup.
Absolutely.
And many times AC systems can't operate under home battery backup because of that on-off peak power demand. It's not very battery friendly.
It's funny you say that, Tim. Yes, we are very deep in a strategic relationship with solar and battery resiliency. If you, and you're spot on. I have those are different slides, but it shows your ability for renewable energy plus storage and to be resilient.
Right. So now you create a resilient home. You have a small battery backup system in the home that you've offered. You can actually still run your AC system, your heat pump, or your geothermal system because you have fairly low energy consumption because it's a pump.
A heat pump's serving all climates. And Bryan made a really good point. I mean, yeah, say Montana or places it gets really cold, you would do some kind of an electric strip backup heat. But for the most part, especially the cold climate, heat pump technology has come such a long ways. So plenty of models that are 100% capacity at 13 below Fahrenheit. Daikin Fit, so this is kind of our flagship product. So this is side discharge inverter. When I work with builders, say they're sales and marketing groups, and you're talking about people in the design center, you know, real estate agents basically, to distill it down to the benefits of inverter, it's comfortable, clean. That's the IEQ part of it because it's not turning on and off. Even if it's minimally heating or cooling, it's drawing air in, pulling it through the filter box, over the coil, removing humidity, and then replenishing, you know, putting air back into the space, you know, air mixing stratification. So you have comfortable, clean, quiet, and connected. Those are all the differentiators of what you see right there. I took out playing the actual sound comparison, but these outdoor units, when running fully, are about the same as a high-end dishwasher, about 57 decibels. So the opposite of that is we all know what a massive, inefficient, noisy cube unit looks like. And you can't do things, I took it out. I mean, like these units you could put on a wall mount bracket. You can just get creative and solve problems in ways you would never dream of that very massive, inefficient, noisy cube unit. And then of course it adheres to any noise ordinances. It's eligible for certain incentives, tax credits, because it hits the efficiencies, et cetera, et cetera. And then just to show the Goodman version, a little more friendly on the price, more balance of price and performance.
Lower SEER level though, lower capabilities?
No, it's essentially the same. I mean, that's the beauty. So Daikin acquired Goodman, went final in 2008, started in 2004. So Goodman as not only just a brand, I mean, I've been doing this for how long I've been doing it, but I've had plenty of builders that have said 15, 20 years ago, like we just stayed away from Goodman.
Yeah, it was a commodity bottom line builder grade. You know, that was the reputation.
Yeah. So now how far we are, you know, Daikin owning Goodman and Amana, the innovation and engineering from Daikin. I mean, I always use the Lexus Toyota analogy, and this is somebody who has 2 Toyotas at home. You know, it's obviously benefited. So there are some differentiating features, but what you see there is essentially Daikin technology. HSPFs, everything is essentially the same.
I don't do anything with HVAC units.
Thank God,
I
because
don't have a heat pump in my inventory.
because we were going to erect a ring and do some cage fighting if you did. I mean, it was going to get bad.
I was gonna win. So hi, I'm Vanessa Wright. I've been working in the new home construction industry for about 2 decades now, and I've had some great jobs. I've been in purchasing, and I was an energy rater for a while and a building inspector. Then I went and became a builder, and then a sustainability manager, and now I work in manufacturing. Been awesome, like ADD on a resume. When I found out I was speaking about energy codes and tax incentives, I was really excited for a few minutes, but not for very long, because I realized the big beautiful bill is taking away my 45L, Come to find out, the best builders always built to that they were building better homes without the tax credits. That was just icing on the cake. But and guess what? IECC 2021 and 2024 are getting adopted everywhere, whether Washington likes it or not. We're going to have to comply. Proactive adaptation has an ROI, and reactive compliance is always expensive. I've seen that happen over and over again, especially as an energy rater. Since IECC 2021 and 2024, these aren't just, oh, you've got to add a little more insulation codes. They're like fundamentally changing how we build houses. IECC 2021 was a 9 to 11% difference more efficient than 2018. They tightened everything from air sealing to envelope to lighting. And then IECC 2024 is another 7 to 8%. This line graph's not updated by the DOE yet, because they're probably not there. But here's some good news. They did add a lot more flexibility with 2024, so there's more compliance pathways, and you're not stuck doing it just one way like you were with IECC 2021. But I know that adding that much more efficiency onto the regulatory code sounds really expensive, and it is. The real cost with it, luckily the NAHB and Home Innovation Research Labs puts together, every time IECC comes out with a new code, they go through and put together a huge analysis that basically goes code by code and looks at every cost code that's going to be affected by that code change. And they take weighted averages from all of the different climate zones in the United States, and they see what those costs on average are going to be for the builders to change, right? It's a really, really fascinating read if you are into sustainability and data. And if you're in purchasing, you should drink while you read it. It's really upsetting, but I think it's neat. I like data a lot. For 2021, the real cost went anywhere from, the increment went from $6,500 to about $9,300 per home. And in some climate zones, it went up to almost $12,000 to suddenly start building to code. 2024, gas houses went $2,400 to $6,400 up, whereas the electric houses went from, I think, $1,600 to $10,000. One of the really interesting parts is some of the climate zones of 2024 had price decreases, and with the R408 compliance pathways, it made the actual cost to build a lot lower and gave you that much more flexibility. They're doing that because they're not trying to bankrupt everybody, which is nice. It used to be that insulation did insulation and electrical did electrical and HVAC subs. They all kind of did their own thing. And what's becoming super obvious now is that all these subs all affect each other. The house is one giant system. And I think it's great that IECC code is starting to force that on everyone. Like, we can't just keep these all in their own little individual boxes. So let me give you an example, like envelope and HVAC. If you tighten up the envelope, you're going to have better air sealing, better insulation, and your HVAC load calculations are going to be off. You sized it for a less efficient home, and now you've got this oversized HVAC that's going to be short cycling all the time. But if you had right-sized your HVAC for a better envelope, you could have purchased a smaller system, smaller ducts, and you just saved a lot of money just in sizing it to the right efficiencies. The electric and envelope, every recessed light, every outlet, every time you drill a hole or run wire, that's punching holes into your air barrier, and your blower door is going to tell. The electric sub has to seal the penetrations, and you're like, it's not my job. And it's like, it is now. It wasn't, but it is now. Building envelope in Levven is where I work. Levven is an example of a neutral and minimal cost innovation that saves you money. And if you see me later on the floor, I'll tell you all about how it takes away about 30% of your cat plate penetrations and about 40 to 60 penetrations out of your drywall, because our light switches are wireless, so they don't penetrate the back of drywall. The modern energy codes are starting to require home performance thinking, and your trades, they're not independent anymore. They're all team members on one big building science project, right? Construction managers need to know what is going into the houses and why it's being installed, and they need to manage the trades with communication and understanding the whole system that they're building, not just checking off milestones in Build Pro. A really tragic situation comes to mind when I think of whole home systems thinking. A few months ago in Nacogdoches, Texas, here, a mom and her 2 kids died because of carbon monoxide poisoning. And I think it was due to a lack of systems thinking. They installed a pool heater that was a little bit too close to the house, and it was venting up underneath the soffit and also affecting the fresh air intake of the HVAC. So it was pooling all this carbon monoxide in the house. And sadly, the father survived, and he's suing everybody. He's suing the builders, the inspectors, the pool company, the gas company. He's suing everybody. And what it's doing is it's just starting, it's ongoing, so it'll take a while, but it's bringing a lot of attention to residential home systems and how improper installation can have just tragic effects, right? I was a sustainability manager at a big production builder for a long time, and I did a lot of cost analysis and value propositions on new products, and I always wanted to get us to Energy Star. And I pushed my initiatives by counting on the 45L. I felt like the return on investment was really obvious. If we were building Energy Star, there's great marketing there, and the other departments in my building company generally wanted to see numbers to prove it. And the only numbers I could point to were utility rebates and the 45L. It was the only actual things I could put on paper to show this is why this is a good idea. One good thing is that IECC 2021 is just about where Energy Star was. So at least we'll still be building that energy efficiency into homes. The new value proposition that works with or without tax is still going to provide lower operating costs for buyers, better indoor air quality, which is very important. Smart features are going to be standard and complies with code. So we're just going to keep building the same good houses we've been building and just tell them they're good houses. Better performance generally equals higher costs. That's the traditional way of thinking. But reality is better processes equal better performance and lower cost, right? So quick examples, if you're doing site-built framing, right? Larry's going to frame one wall one way and Jim's going to frame one wall one way, and they're going to end up in a corner, and there's going to be thermal bridging, and your insulation guy is going to have a panic attack because they didn't do it the same way, and they don't have proper cornering and oversized HVACs. We know that that's a huge problem with you're going to pay more money for bigger equipment that is literally going to perform worse. Like that's what oversized HVAC systems do.
And then you have humidity problems.
Then you get humidity problems that lead to mold problems and warranty costs through the roof. They say that the big future is going to be in offsite manufacturing and prefabricated. I'm sure a lot of y'all have read Sam Rashkin's Housing 2.0. He also has classes, and maybe track them down at a conference and force them to sign your book. I have. Anyway.
So you're an admitted stalker?
Oh, absolutely.
Oh, very good.
Yeah, I got to have Patagonian toothfish with him one time. Of the 4 disruptions that Sam says for sure is looming in our future, he says that offsite construction is probably the biggest one. I can't cover it as great as he does, but he says it's going to improve quality and reduce cycle time. And when they do it at scale, it lowers the cost for actually building. Factory installed air barriers, they're going to be better quality control than field installed. I'll always be a lifelong fan of aero barrier as an energy rater, but giving them less things to seal up is a good idea. We got BIM modeling coming out in Frame Tech. Their framing systems have less than 1% waste. It reduces labor and so much time from design to delivery is about 14 days. I was at an amazing construction site not too long ago that had 3 Frame Tech frames going at the same time, and there was one 4x8 trash box between all 3 sites. And I was like,
there's nothing to get
what are you throwing away? There's nothing to throw away.
Have you ever modeled at Levven, though, the thermal savings of all the switches on the outside walls? Because you sit there, you got a 3.5-inch cavity, and your box is,
I want to do
2.5, 3 inches deep, and it's like, so there's hardly any insulation behind it.
No, it's always just a bunch of poly.
And you got the wires sticking out the back, so you got those little things all over the house. It's like, what does that end up with? Is that like a 4x4 kind of cold spot in your home in the end? And then what does that actually cost you from an operations perspective?
I can tell you that there's a model home that I put one in one time, and it was December, that's why I remember what it was. But it was, and I was in New Mexico, and I could feel so much air coming out of the outlet. I borrowed a lighter from the builder, and I just couldn't even get the lighter anywhere near. It was just freezing air, and it was an interior wall in an Energy Star new model. I was just like, well, so I'm going to convince my boss someday that I need a pan hood so that I can actually get my manometer and measure and see how much airflow comes from the average exterior and interior.
Yeah.
Every day a house sits $150 to $300. So 1 day saved per home times 50 a year can be up to $15,000 in savings. 250 homes a year can be up to $75,000 in savings, and that's just saving 1 day on a build cycle. Average warranty trip about $175 to $350. There's a great website called warrantyweek.com that reaches out to the big builders, all the big builders, and it gets their annual reports and compiles all their data. New home builders reported almost 1.1 billion in warranty claims paid in 2024, and that's actually a decrease from 2023.
Well, what I always find amazing is we gave a marketing a talk once, Build, about how could you really differentiate new homes from used. And we took a play out of both Volkswagen and Hyundai, the car companies. Volkswagen had that huge diesel emissions scandal. They needed to do something, right, to get consumer confidence. And when Hyundai first came to the United States, they were trash. They were absolutely the worst reliable car you could get, and they were losing their reputation. And both of them, if you remember, came out with 10-year, 100,000-mile warranties. Just said, look, we got you. And by the way, doing that, they completely improved their products, and now they're really reliable products. The weird thing about a home is you buy a $500,000 home and you get a 1-year warranty. What's supposed to break in our home in 1 year? Really? The dishwashers? That's it? It's a 1-year disposable item. The refrigerators, 1-year disposable. The stoves, 1-year disposable. The HVAC systems, 1-year disposable. I mean, you look at it, the warranty on home products is terrible. And the question is, could we as an industry force the industry to go back to say, look, we're going to give you at least a 5-year door-to-door warranty on anything in a new home? And force that back to the manufacturers. That if you build right, you engineer and design your systems, nothing should break in your home in 5 years. And if you did that, you'd have differentiated product offering in the market and it wouldn't cost us anything because the manufacturer should know that the product will last 5 years.
Better envelope really means 20% lower utility bills versus comparable homes. Ventilation requirements should say something more along the lines of hospital grade air infiltration system to improve indoor air quality. LED requirements mean lifetime lighting. You'll never change another light bulb. R404, whole home intelligent control system. Sometimes when we just build the code, they look at it like it's substandard in some way, and they had to build a better envelope. They had to meet ventilation requirements. I think it's up to the builder to educate and explain to their buyers what that really means and to use language that makes it sound like we built you an amazing home. We didn't just build you a bare minimum generic product. We built you a great home. But I think that goes along with having education for those home builders. We copy California and all the codes pretty much, but they're doing embodied carbon tracking, and that's also pretty prevalent in Canada already and other places across the globe. We're going to have grid-ready requirements as far as EV charging and solar-ready infrastructure, passive survivability, which is homes that'll still work during power outages. I think the way that builders can get ahead of this is to join collaborative industry groups, being a part of the HBAs and the code councils. Not only do you get to learn about everything first, but you get to have input, partnering with manufacturers that do a lot of R&D, that care about the research and development of their products. They see trends and code adoptions 2 to 3 years before because they're already on those code councils to help influence. We were at EBA, EBA, ResNet, they're all very, very involved. PG&E, IECC, they all have so many free classes. Building relationships with progressive inspectors and raters and building science geeks. They love to guide you and tell you, and they're usually very passionate to discuss all of it. And test innovations in model homes. I think that's really important for builders to always do. Don't test it on customers, and you should try it out before you go to scale.